Here is another problem in our current topic, that is simple stress. At this time we will deal with shear stress. What force is required to punch a 20 mm diameter hole in plate that is 25 mm thick? The shear strength is 350 meganewton per meter square. From definition, shear stress is developed. The applied force is parallel to the resisting area. It can be depicted by this figure below. So if a force B is applied to the short cantilever beam, the resisting area which is parallel to that force is just equal to the area at the overhanging end of the cantilever beam. If force P is applied to this material, then the resisting area which is parallel to that P is equal to this rectangular area. It can be depicted by this part of the material. Another type of shearing stress is punching shear. If you try to punch a hole at this plate, which is illustrated by this figure, then we can see that the force P is parallel to the area which is shearing, and it is equal to the perimeter of the hole being punched multiplied by the thickness of the material. We will go back to our current problem. So we will identify the resisting area, that is step 1, in order to solve for the problem. From definition of shear stress, force is parallel to the resisting area. So we can now solve for the area that is just equal to the perimeter of the hole multiplied by the thickness, that is 25 mm. The perimeter of the circle is just equal to pi d or 2 pi r. Then thickness is equal to t, so we can solve for area that is equal to pi dt. We can now apply the formula to solve for the problem. Tau is the symbol for shear stress, and that is just equal to P all over A. For area, that is just equal to pi dt. This is the diameter and the thickness of the plate. That is equal to 1570.8 mm square. And for tau, that is given in the problem, that is the shearing stress, 350 megapascal or Newton per millimeter square. If we now solve for P from this equation, that is just equal to tau multiplied by the area. So tau is just equal to 350 and area is equal to 1570.8. We can solve for the force required to punch the hole, and that is equal to 549,780 Newton, or that is equal to 549.8 kilonewton. I hope that you have learned a lot from this example. Those who want a copy of this file in PDF, like and subscribe, comment down your email below, and I will send it to you. Thank you.